And so I talked to you already about this kind of metaverse, the real world metaverse, right? This kind of digital content layer on the real world. And there's a concept of so-called spatial anchoring. And that means I can, just like a ship throws out an anchor and it will stay and see out the anchor, this space anchor will anchor virtual content in the real world, right? So I could basically go out here and put so-called spatial anchor there in the real world virtually, and then my device, if I come back at a later time and just scan it a little bit, so with computer vision AI, it can analyze where I am. It can then relocalize myself and find, okay, Rene left some information there, some virtual information, and it will load that again because I'm anchored in the real world. That's all about what it is with a spatial anchor. And so you can enable these kind of multi-use cross-platform applications, like you can see here in a little video, gentleman using a tablet and then using that anchor and then sending that into the Azure Spatial Anchor Storage, which is a cloud storage basically, where this anchor is then being stored, and then a HoloLens, like a whole different category, like I mentioned to you, like more sensors and so on. The HoloLens then comes into play, takes the anchor, the person with the tablet uploaded into the cloud, and since the HoloLens now has the same anchor, it matches this into the tracking of the HoloLens, and then it can see the exact same information at the exact same position and orientation, at the exact same pose, as we say in computer vision. And that is already a mind-blowing achievement, because again, that allows us to have this heterogeneous devices share virtual content together. But you cannot just share cross-platform or share across devices, but you can also share across time, because you can persist these anchors. And I will show you an example in the next few slides why I basically just did that, where I persisted an anchor in front of our house and came back at a later time. And the third capability is these kind of wayfinding, indoor wayfinding, navigation applications, right? Because you have these anchors, like I mentioned, put an anchor here, put another anchor there, and then another one, and so on. And so you can connect those and enable these kind of wayfinding scenarios, like through a large real world scenarios. Because we have this real world metaverse on top of our real world. We can put anchors on our real world metaverse, and then we know where we need to go. And we can even, attach, of course, meta information on top of that. Long story short, let me show you some examples what we built. One of them is, for example, here where you can see an application we developed. It's running on mobile here, and I'm loading an anchor I saved in front of my house. And you didn't even see how fast it was being able to relocalize it. But basically what I did here is I loaded the app and then, opened, okay, I want to find that anchor. And then I scanned with my mobile phone just a little bit in front of the house so it recognizes where I am. And then basically it found out, okay, Rene is at the same spot. He left this anchor, before, and then it loads that anchor and then also loads the 3D model I attached to it, which, as you can see, while Christmas is upon us soon, hopefully, is a little wooden Christmas Santa figure kind of a thing. My uncle makes those. It's pretty fun. But anyhow, it's a 3D scan, as you can see from the real one, right? So I can put the digital twin, the 3D scan of it right next to it. And this 3D scan, folks, was done with a mobile phone, right? So it's also this amazing part we are enabled with this spatial computing age. We can scan anything, like everything we can see in the world, we can capture and use it in the metaverse later on. And that's all of these, like I said, all of these things are beautifully coming together. Real quick, another example where I took some old video footage and put it into the city. So I live in Dresden, Germany, which was, World War II happened, many, many decades ago. And thankfully, a lot of the things were rebuilt in town. You have to know, like, Dresden was heavily bombed in World War II, at the end of World War II. So a lot of places look different. But a couple of things, or most of the things were rebuilt, but not everything. So what I did here in this little experiment, I created these, what I call time machine portals, or AR historic portals. And what you can then see here is an old video from before the war, from 1946, an old black and white footage, put in the real world, and I can have this portal back into the old days and can compare it with recently, right? If you see the two church towers there, for example, the Sophia Church, that was not being rebuilt. So if I walk around the portal, I can actually see, okay, well, that looks different today. And all of that is, of course, also possible to enhance with a little bit of AI. So there are a bunch of AI models available that can increase that old footage. So you can, colorize it, first of all, automatically AI colorized. It's just like mind-blowing, right? Second part is 60 frames per second frame interpolation. You see these smooth animations. And then 4K resolution, right? And all of that, a few AI models. Eddie Wu, my friend, helped me with this one. And so you can put these kind of portals, video footage, what it is in the end, it's a 2D video text, or you can put it in the real world. Thanks to this Azure Spatial Anchor technology, you don't have to put a QR code anywhere. You don't have to, write something down or have the user manually search with GPS. This is really precise. This is not using GPS. This is using computer vision. So it scans the camera data, basically. And with this, we get a precision in its centimeter range, instead of GPS, which is in the meter range of precision right now, at least for us normal people, not military, right? And so that technology enables us to put these kind of real world experiences without any AR marker, without any QR code. The real world becomes our marker. And that is just fantastic, because we can enable such kind of experiences. We can put 3D models, we can put videos, photos, whatever, we can put it in the real world and anchor it there, and then share with other people, and they can all come together. Here's another game or a gamified experience I created. I call it the fruit hunt game, and you can think about a scavenger hunt game. Basically, the city, and you need to find those, and that's the challenge here. And it's basically just a tech demo, with Azure Spatial Anchors, with this anchoring on top of the real-world metaverse of the AR cloud, if you will. And so Microsoft is working on that. You also have other companies like, for example, Snap is working on it as well, on their own kind of digital content layer, real-world metaverse, if you will. And this is a demo where they released a beta in London in Carnaby Street, where everyone can try it out. Well, not everyone, but it's a beta enabled there. And basically what they built here is what I keep on saying, like, since a few years, the real world becomes a canvas, right? And you can see it here really nicely, how all these people can have some fun together, share it together, and even persist what they did there. And right now, as you can see, they're all using mobile phones, but in the end, we might all want to wear something like this. You can see these beautiful, beautiful depends on everyone, right? But these goggles, these are the Snap Spectacles, the Creator Edition, and these are true AR glasses, so more comparable to a HoloLens, where you see virtual objects, right? And that might be the headphones of the future, right? We put on these AR glasses with a nicer form factor, but right now, of course, it's a lot of that is mobile-based. You also have Niantic and a few other companies working in that field, and yeah, amazing stuff you can do there.